Based on the examples, we'll need two new values, variant v and constructor v. A variant v holds a symbol tag and a value, and a constructor v holds just the tag. One example of a constructor that we saw before is this one, constructor v with the tag apple. We should be able to apply that constructor value to a well-typed argument like int v1. And when that happens, the result we want to get out is a variant v that combines the tag apple with the argument 1. Here are the two expressions for let type and match. These are big expressions with lots of fields, as we're keeping things simple. There's a lot of info that a let type needs to keep track of, but it's not an arbitrarily large amount of info like we had for objects and classes. So we have to keep track of these 6 things, but it doesn't make sense to bundle them into lists. We'll just have to deal with the 6. Same goes for match. There's a lot to keep track of. First is the expression that we're matching on. Second is the type name for that expression. And then we have 3 things for each case of the match. First, a symbol tag, then an argument name, and finally a right-hand side or body expression. Lastly, we have our new type, defined t, and a defined t packs up a symbol name. And this name will refer to something that was defined with let type earlier on. As a reminder, here's the concrete let type syntax that's going to expand into this abstract let type e. And here's also the Mo syntax for a match. And this shows where those 8 pieces all come from. For interp, we can start with let type. In this case, it's fairly straightforward. The real action in a let type e is to interpret the body. But before we can interpret the body, we need to extend the environment for the 2 tags that we define as the 2 variants. And each one of these tags should point to a constructor v. So that's exactly what happens down below. Tag 1 is a constructor v for tag 1. Tag 2 points to a constructor v for tag 2. With this example for a fruit type in mind, the fruit would be the type name. Then our 2 tags for the variants are apple and banana. And we can ignore the argument types because this is the interpreter. Those types are only important for the type checker, and we'll get to that later. The more interesting thing with the interpreter and let type is what happens when we apply a constructor. For this, we go to the app case. In addition to applying a closure, we need to be able to apply a constructor. When we do, we use the tag inside the constructor as the tag inside of a new variant v, and the value inside that variant is the result of interpreting the argument. Back again to our fruit example, when we apply the constructor for apple, we'll see that apple is a constructor v with the tag apple, so we construct a variant with apple, and then 10 is the argument. So we interpret 10 to get the value that goes inside the variant. For match, we have a bit more work to do. To implement a match e, of course, we'll use split's match. Match on the result of interpreting that test expression. This expression needs to give us a variant, otherwise we'll raise an error. And if it is a variant, we check whether the tag that we have is equal to tag 1 or tag 2. That tells us which body expression to evaluate, right-hand side number 1 or right-hand side number 2. And whenever we interpret those, we make sure that we extend the environment to bind the match variable. If we're matching on the variant apple 10, then we'll see that the tag for this value matches the tag apple. So we'll extend the environment to have a bound to 10 and go on to interpret the right-hand side 1. If we were matching on a banana, we'd go through a similar process. We'd see that the tag is equal to banana, and we would go down the second right-hand side branch with a binding for b.